All right. Hi, everybody. This is Christiana from the team over here at Coiled. Welcome to our June webinar, Workflow Orchestration with Prefect and Coiled. We're going to give everybody a chance to join in before we get started and before I introduce our guest today. So feel free to jump in the chat, tell us your name, where you're tuning in from, and we'll get started in just a few minutes. So thanks for joining. Hi, everybody. This is Christiana from the team over here at Coiled. Thank you so much for joining us for Workflow Orchestration with Prefect and Coiled. We're going to get started in just a few minutes, and I'll introduce our guests today, Jeremiah and Kevin. But in the meantime, feel free to jump into the chat, introduce yourself, tell us where you're tuning in from, and we'll get started in just a few. All right. Hi, everybody. My name is Christiana. I'm on the marketing team here at Coiled, and thank you so much for joining us for Workflow Orchestration with Prefect and Coiled. I'm very excited that today we're joined by Jeremiah Lowin, founder and CEO of Prefect, and Kevin Coe, Prefect's open source community engineer. for a discussion on updates about Prefect generally. We'll learn more about the company. We'll go over a newly released feature called the KV store, and we'll learn how to use Prefect and Coiled together. So quickly, just a little bit more about our guest today. So Jeremiah Lowin, again, is the CEO of Prefect. Over his career, he has directed risk and technology for very large financial institutions and designed machine learning software for startups, getting hands-on experience with almost every aspect of the modern data science stack. Jeremiah lives with his family in Washington, D.C. and loves to see the local data community grow. Kevin Ko is an open source community engineer at Prefect. Previously, he was a data scientist at Paylocity, where he worked on adding machine learning features to their human capital management suite. Outside of work, he's a contributor for Fugue, which is one of SQL interfaces for Dask. And he also organizes the Orlando Machine Learning and Data Science Meetup. So without further ado, I'm going to pass it over to Jeremiah and Kevin. We'll hear a little bit more about Prefect from Jeremiah generally, and then Kevin will walk us through the KV store, how to use Prefect and Coiled together, and then we'll come together at the end and do Q&A, have a casual discussion. And as we go, feel free to enter questions in the Q&A or the chat. So without further ado, I'll pass it over to you, Jeremiah and Kevin.
Thank you so much. Thanks for having us. There's so much that we would love to cover. I don't know if we'll be able to fill it all in. So I'd love to talk a little about what we're up to at Prefect, why we're so excited about the future and sort of what we're building. Kevin and I are very excited to share this brand new feature that we've released, this KV store, which is really interesting in its construction and sort of how simple it is, but the sophistication of the use cases it enables. And then of course, would love to leave as much time as possible for just Q&A. Would love to hear from everyone who's attending. I see a lot of familiar names in the chat, so I hope you all continue to introduce yourselves. It's really nice to connect with you virtually here. So Prefect, for those who are unfamiliar with us, we are the company behind Prefect, the open source workflow engine. And we have been around for 3 years. We're having a very exciting year in 2021. We announced our Series A very early this year. We announced our Series B last month. We're growing like crazy. We're hiring. We'll talk about that later. I just got the numbers that Prefect Cloud is now processing 150 million tasks this quarter, which is 3 times what it did all of 2020. So just, it's incredible to see the software take root, take hold, and grow. So why do we do this? What's exciting to us? We solve this problem that we call the negative engineering problem. And negative engineering is all of this defensive code that we write as data scientists and as data engineers to make sure that the things we want to achieve in our business or our personal lives actually takes place, actually happens as expected. So you want something to run at 9 a.m., great, throw it a cron, you're done, you go home, but then the data's malformed or the internet goes down or the computer crashes or any number of infinite failure cases. How do you put defensive measures in place? And of course, every engineer reaches first for a try except, and then for some sort of infrastructure that'll govern it. And you very quickly just end up in this sort of maintenance hell. And we call that the negative engineering problem. It really has nothing to do with the business purpose you're trying to achieve. You want to run this analytic, you want to produce this report. Our job, therefore, as an orchestration company is to provide tools that are as simple as possible so that our users can just snap them together like building blocks to achieve whatever purpose they have, whether it's scheduling, logging, retrying, dynamicism, fan out, interfacing with different executors, or as Kevin's going to show today, storing state across runs in an interesting way. So that's the problem that we're dedicated to solving. We do that with an open source package called Prefect. We do that with a commercial platform, a SaaS platform called Prefect Cloud. And maybe later I'll take some questions about that and the future of that. But for now, Kevin, maybe I'll hand it over to you because I think you've got a good overview of sort of those products and also this specific feature we wanted to show today.
Yeah, I'll share my screen. You see my screen, right?
Mm-hmm.
Okay, so yeah, hey everyone. It's nice to see familiar names in the chat. It's also nice to meet new people. So if you're not familiar with Prefect, I'll try to give you a brief overview also. And if you're a Prefect user who's not familiar with Coiled, we'll show how these two tools play well together. So for what we're going to show today, first we'll just give a brief introduction to Prefect for those unfamiliar. And then we'll talk about the how to use Prefect and Coiled together, where you can use Coiled as a Coiled cluster as the executor for your Prefect flow. And then lastly, we'll be showing the new KV store feature and giving some use cases. If there's time, then I'll give a brief demo of this also. So a bit more about Prefect. You heard Jeremiah talk about negative engineering. And when we talk about negative engineering, we're talking about those try excepts. How do you retry API calls that fail? What do you do when data is malformed? Or how do you get notifications that your pipeline has failed? What do you want those notifications to have? So these are things that we call negative engineering, and it's Prefect's mission to eliminate negative engineering. So what we want to do is we want to allow people to stop writing, minimize the amount of code that they write towards negative engineering and actually write more code towards the use cases that they set out to solve to begin with. And that's where the Prefect, the product helps. So Prefect is an open source workflow orchestration tool that's Python based and really designed to handle the modern data stack. So one of the things with older data workflow orchestration tools is that they were not equipped to handle with the volume of data that comes in today. And Prefect was really designed to tackle that. We have a very active community, both in Slack and GitHub. So our Slack community has upwards of 6,500 people now. My job, 80% of my job is supporting the Slack community. So if you have any questions on how to use Prefect, or you want to just chat about workflow orchestration, you want to compare Prefect to other things or see how it fits in your stack, then we would, you can just drop a question and we'll be happy to answer you. There are a lot of other people who know a lot, and I definitely learn a lot managing this community. There are a lot of people way better than me. And then Prefect also has two offerings in the Prefect Cloud and Prefect Server. Prefect Cloud is our managed offering. Prefect Server is entirely open source. You can go set a Prefect Server on your own company infrastructure, but Prefect Cloud is also free to get started with. We provide 10,000 free task runs every month, and we only build successful task runs. So there's more than enough to get started with. So you can literally go today to Prefect Cloud, sign up for an account, and have a test drive with it. Prefect also has a native Dask integration, and that's one of the reasons why it plays very well with Coiled, and I'll be covering that later. Even though Prefect is Python based, I see a lot of community members who are not so strong in Python, but still use Prefect to orchestrate workflows because of the task library. So because all of our tasks are just written in Python, then it's very easy to extend it to build tasks using the API of other tools, the Python API of other tools. So a lot of the standard workflows can be completed using a combination of the tasks available in the task library. For example, you want to download data from an AWS S3 bucket and upload it to do some processing and upload it to PostgreSQL. Maybe you want to send some Slack notification or run a command with the shell script. Having the task library allows people to get started with Prefect very quickly and build ETL pipelines with these off-the-shelf components that they just have to configure a bit. Prefect comes with most of the standard features you'd expect from a workflow orchestration tool. We have parameterized flows. We take care of retrying tasks when they fail. For Prefect Cloud users, we hold secrets. And then you can also have conditional logic where you can decide which path of your DAG to take depending on the results of previous tasks. And then, of course, we take care of scheduling your workflows. Here is a sample image of our UI. So here, the red are failed flow runs, the green are successful flow runs, and in the yellow, you'll see the scheduled flow runs. This is interactive. You can go in, you can click these flows, see which tasks succeeded, which tasks failed, and then you can also we also have if you see at the top here, we have an interactive API where you can also interact with Prefect using this API through a Python client or through this API interface over here. And with that, I'll be hopefully that I know that was a brief overview of Prefect. But if you're interested, if you're not familiar with Prefect yet and you want to see more, we definitely have other content that you can check out. Just feel free to ask me for it. Maybe I'll include it in the chat. So now we'll talk about the relation of how to use Prefect and Coiled together. And in order to understand how these two play together, for people not familiar with Prefect yet, I'll just show a brief code snippet here that shows how you would construct a Prefect flow. So flows and tasks are the semantics for Prefect orchestration. Flows are more like full Python scripts, where tasks are more like individual functions or individual pieces of logic. And you'll notice that all I have here is Python code. This is all Python code. This is just a function that will pull data from an API and put it in a pandas data frame. This will just detect it. All we need to do to bring it to Prefect for orchestration is wrap it with a task decorator. So Prefect is a very Pythonic interface and very non-invasive to your already existing code. And then to bring it to a flow, all you have to do is use this flow context manager. And these are the tasks that we defined earlier. I won't cover this posting to Slack, but there's a lot of interesting things here. So first is you have the first class passing of data because through this Python interface. And then there's also automatic setting of dependencies. So now this detect dip knows that this get data is an upstream task because it received the output of this get data task. And the nice thing about Prefect is also this flow.run command, so you can test your flow locally. You don't need to spin up services in order to test your flow. And that brings us to mapping. So mapping is one of the more advanced Prefect concepts and also one of the more unique ones. So using mapping, we can dynamically alter the DAG that's constructed by Prefect. So here we can have a list of inputs instead for the cryptocurrencies. And then we can use the map operator to run this task on each of those inputs. And because we have two consecutive map operations here, these tasks will actually be connected to each other so that so that they'll just be executed in a depth first execution manner independently of each other. Although here I have a reduced task, all I'm doing here is getting the data, seeing if there's dips, and then seeing if any of them indeed have a dip. So the max, this is a list of true or false values. The max of that would tell me if there's a dip, and then if there is a dip, I'm posting to Slack. What's really nice about Prefect's mapping is that if you look at the task we defined earlier, this only takes in 1 coin. So we didn't have to edit our function. And all this function has to care about is the logic for one of those cryptocurrencies, just 1 coin. But then when we provide the list, we can just call the map operator and have this task execute on each of those independently. So when I provide a list as that parameter and using the map operators, we get this span out type of operation, and it's gonna execute in a depth first way. So we have this get data for the Bitcoin, and then we're detecting the dip of the Bitcoin data. And now these are executed depth first, and also when you use Dask as an executor, it's done efficiently such that there's no persistence. So these will execute one after the other on the workers already. And because of that, it's very efficient and has a lower overhead to run these iterated map operations. And that brings us to Dask and the DaskExecutor. So For Prefect, uh, the default executor is the local executor, and that just runs things in a sequential manner. But if you want to take advantage of parallelism, we have both the local DaskExecutor and the DaskExecutor. The local DaskExecutor will just use the cores available in your machine. The DaskExecutor will take care of actually running your flow on a cluster. So now, when we do these map operations, we can pass those over to the DaskExecutor workers and run them there. And we don't have to worry about altering our previous logic. So the DaskExecutor is a way for Prefect users to actually take advantage of the parallelism provided by the Dask engine, even without having to write Dask code. So here, all the Prefect users have to be concerned about is the map operator, which is a Prefect thing, and it will take care of mapping out Prefect code over to Dask. I see some activity in the chat. Okay, nothing. So now I'm going to talk about the Coiled Executor, using Coiled as the DaskExecutor. So this DaskExecutor takes in a callable as the cluster class. So a lot of people will be passing something like a Dask cluster, a Dask Cloud Provider cluster or Fargate cluster. Here we can just directly pass the Coiled cluster and provide the arguments to that Coiled cluster. So if you're not familiar with Coiled yet, and you're coming from the Prefect side, Coiled has a really nice interface for building Docker containers. So here, I'm using this Coiled create software environment method or function. And what's going to happen is this my conda dependencies and also pip dependencies will be packaged together, and it will create a software environment for me that's hosted that'll be available in my Coiled account. And then when I create the cluster, I can just use this, because this was named Prefect and my account is KVNCo, I can just use this KVNCo/Prefect software environment on this Coiled cluster. So it's going to spin up that Coiled cluster, load the Docker container on all those workers, and have all those dependencies set. And then it's going to run my flow. And then because of the shutdown on close, it will just turn off the cluster when my job is done running. And then I can attach this to my flow by setting flow.executor equals this executor. And this is much more convenient, in my opinion. A lot of our users tend to struggle with things like AWS ECS, where there's a lot more moving components, and Coiled really provides like a simpler interface for building a container, hosting that container somewhere, and then loading that to the DaskExecutor during execution. So it's a lot easier to get started with than other cloud services where they do the same thing, where they have you have to upload the software, the Docker image to another service, and then load configure like the runtime to get that, and you're juggling a lot more services. And that brings me to our main topic today, or our new feature that we're going to show today, called the KV store. So the KV store is a key value store that was released in early June. The keys are strings and the values are JSON, and the maximum size of a value is 10 KB. So it's not meant for secrets. This is not like stored in some secure way. It's really meant as a caching mechanism, and that allows people to store small bits of state that they can use across flows. And then right now it's only available in Prefect Cloud. So there are a bunch of different ways that you can access the KV store. The first way is using the UI. So you can simply add a key value pair using the UI. And then aside from that, as long as these require authentication, but you can use Python. You can have it in your Python script where you use this get or set key value function call. And then you can also use the command line with this prefect kv get or set, and then the key value pair. And then lastly, we also have the GraphQL API where you can, same thing, get, set, or delete values. So the get, set, and delete operations are the main operations in the KV store. All of them are available through the UI the command line interface, the GraphQL API, and the Python client. And then there's also one more operation where you can list the keys in your KV store. Access to keys and like operations on the keys can also be limited for Prefect Cloud users who have role-based access controls. So let's talk about some sample scenarios of what pain point this KV store addresses and why we think it'll be very useful for our users. So the first scenario here is is to persist some sort of watermark for ETL pipelines that are mainly concerned with pulling new data, or what we call, or the difference between what data has already been processed and what data is available in the raw data. So the delta between those two. So we want to keep this watermark to avoid duplicate processing. So what's going to happen is we have, if your raw files are partitioned in some way, where maybe by date, where the new files are always coming in, then you can use the KV store to figure out what the last process date was. And you could only pull unprocessed data, maybe use Coiled to transform that or process that in some way, and then upload it to Postgres SQL. So if the flows somehow fails during the process, then this does not get updated, right? Because it only gets updated at the end. So when you restart your flow, if you run your flow again, it's gonna see which files were still unprocessed and pull the correct delta. This is also a very flexible system if you're running ad hoc flows, like you really needed to refresh your data. So you could pull the data, and then the next time the flow runs, it will already see that stuff was processed. So there won't be duplicates. A lot of times, without keeping track of this watermark, you're going to run into issues of like duplicate entries into the database, or you're going to have to query your database to get the maximum like process value, and then use that in your script, in your flow, to figure out which files to pull. In general, that's a very, like, especially if you have a lot of data, that's significantly more expensive than simply using the KV store to just keep track of this state. Also, if you have a lot of different data sources that are in sync with each other and get updated at the same cadence, the KV store is also a good solution for that, where you can, since this KV store is takes in a JSON, you can have the state for multiple tables in the same key value pair. Second scenario is when you need to store just relevant pieces of information that update at an irregular interval. So if you think of a scenario where you're keeping track of stock data, and like you're concerned about like what percent is this compared to the all-time high, then that all-time high can be stored in the KV store as a value. So you would pull the stock data, maybe transform it based on the all-time high values, and then have some Slack message, or maybe it's currently at the all-time high. Then you would post something, and then you would update the KV store again and have that new all-time high value persisted, so that the next time your flow runs, you can have that all-time high be used in terms for your comparisons or your analysis and stuff like that. One thing I also had at my last job is we had to version all of our models. So for all of our machine learning models. So in this case, you could store what version you're on in the KV store, or like what version to use as like for us, we had multiple versions of feature sets for machine learning. So we would something like persisting which version to use. And this version may not necessarily be like something numeric. It can be something, like version 1A, 1B, 1C, and like you decide you want to use 1B for your production pipeline, then you can persist this. And now all your pipelines that rely on this version will be in sync that they want to use 1B, that version 1B. So a lot of times in machine learning, you're going to have your training pipeline and your inference pipeline. You can use the KV store to sync both of those pipelines and have them use the same version. So here we would, what we would have done if I did what I did at my last job like differently, is that we would persist a version in the KV store, and then we would add that to our data and market, and before pushing it to our database. I've seen this scenario pop up a lot in our community, where one of the strengths of Prefect is that we have this flow of flows type of model, where you can have different executors for different parts of your pipeline. So here, if each of these are separate flows, the train model flow is normally more compute intensive. So for something like training a model, you could spin up a coiled cluster for that, but for the other ones, you don't need this much processing power. You can use just like your local executor. So you can change the executor for each of these subflows if you separate them out this way. So one of the I've seen this use case in the community where they would check if new data came in. If new data came in, they would run the whole thing. They would process new data. They would train the model, deploy the new model. But if there was no new data, then they would want to short circuit this entire process and not have that. This was a pain point that our users experience. It will be cleaner in 15.0 in our next release also. But the KV store is one potential solution for this, where this check for new data writes out if new data actually came in, like a true or false. And then these succeeding pipelines can check if new data actually came in, and they can just short circuit because we persisted this state that they can retrieve. The last scenario that I'm gonna talk about is, and show somewhat a demo of, is you can use the KV store to output artifacts, like small artifacts from your Prefect flow that can then be used by other services. So here, all we would need to do is to have AWS Lambda authenticated. And if it were authenticated, it would be able to access the KV store and pull something. So for example, we have a machine learning model job that runs, and we want to output the path to the latest model. We can just persist that in the KV store. And then on the AWS Lambda side, it would just have that key would be constant, like what is the model location. So all it needs to do is get whatever value is attached to the model location and then deploy that model or use that model on the inference or prediction side. And I have a brief demo, but before I get there, the slides will be sent out. I will type these in the Slack, in the chat also here. But in general, just wanted to give some resources here. There is a Coiled documentation piece on how to use Coiled and Prefect together. We also have a blog entry that introduces the KV store. And we are also hiring in a lot of different roles, both technical and non-technical. Maybe Jeremiah will add to this later, but if you are interested or you just want to chat, feel free to email me at kevin@prefect.io. I'm always on Slack, so you can reach out and join our Slack community, ask questions there. We're always willing to chat, even if you're not applying to these positions specifically, and you just want to chat about what working at Prefect may be like. We're always we always entertain like whoever wants to chat. And then I have a link to the job postings here. And with that, I'll give a brief demo. So here I have a Python script. This is based very much on what I showed earlier with the cryptocurrencies. All you need to do is that all you need to know is that what this thing is doing is it's gonna pull the most relevant data, and then it's gonna fit a simple model, a RIMA model for those familiar, on this data, and then predict the movement of that price for the next couple of intervals out in the future. And then we have a plot that we will be saving to S3, and then we will use the Prefect artifact to store those plots. And then after this is done, so if we were training like a machine learning model, like my last example, and we wanted to persist the location of that somewhere to be used by other processes, then I would set a key value pair where this will be my model location, and this will be the folder where that lives. And then you see the create software environment here, which I won't run because it builds the container, so it'll take some time. And then the DaskExecutor, where I use the coiled cluster. So over here, I'm just gonna, this is my flow, and all I'm gonna do is run this. Well, first of all, I should show you that this model location, it will be updated when I run this flow. So I'm gonna hit the quick run. You're gonna see a new flow run appear. If actually, let me check if I have, yeah. So this yellow is our new flow run that's being created, and it's gonna turn blue when it starts running. And this will take some time because we have to spin up our coiled cluster, and you're gonna see the coiled cluster started to spin up already because of this flow run that was triggered. And if you check the logs here, you're gonna see that it's creating the new coiled cluster. The name of this flow is Auburn Dogfish. So you're gonna see this model location get updated with this Auburn Dogfish. And this will take some time. So I'll hand it over to you first, Jeremiah.
Sure. Let's talk for a second just about this feature, like the KV feature. Or do you want to address maybe this question that just came up?
Yeah, is
Kevin?
there? Yeah, the question, is there any difference in having import statements inside a task versus outside? Yes, there is. Task execution is deferred. Some people use that in order to register flows that they don't have on their machine. So like the module doesn't exist on my machine, so I'll import it inside that task and use it inside that task, so that execution is deferred. So I hope that answers your question. And outside at the top of the Python file would be just, evaluated immediately.
There's a little bit of artistry there that first the graph is evaluated on the machine that's running it, and then it's sent out for execution potentially on the Dask cluster. And so there is some strategy in where your imports are and where your dependency are, and little art over science there.
So this flow actually completed. So I'll just finish this demo first. So here we're gonna see that this coiled cluster will spin down. Over in S3, I'm gonna find a new folder called this Auburn Dogfish. And what happened here is that I made the plots for each of these cryptocurrencies, and then I used them as artifacts here on the Prefect in the Prefect dashboard. So over here, if I click my latest flow run, I can check the artifacts, and these were prices, and this is the prediction of the model, and these just happened in that flow run, right? So this is for Ethereum, for Bitcoin. But then added to that, the more important part of this demo is that if we refresh the KV store, we should see that the model location updated to this Auburn Dogfish. So now if I use like an AWS Lambda and I pull that down, then I would get the most updated model. I could also use the command line, prefect KV get model location, and I would pull this JSON down to my command line also. So I could also use it in processes that are command line heavy also. And I could also set stuff from the command line, just to clarify that. And with that, yeah, I'll hand it over to you, Jeremiah. That's it I have.
Cool. Thanks, Kevin. So I love this feature, and I want to talk for a second about it and also artifacts, which you just showed, and how we think about the different features that we develop and the use cases that they enable. I think one of the challenges that we have, and Tom, I see your question. I'll talk about roadmap. I'll talk about roadmap in a moment. Yes, is a short answer. In a specific way. All of the features that we work to develop, we have this challenge in that people use Prefect for that negative engineering component to enable whatever their business case is. And so we have to be very careful when we deliver a feature. Our job is to make sure that it's compatible with whatever that use case can be. And often because of how even our SaaS product works, we don't have access to the code and data that our users are running. It's one of the reasons that we care so much about building relationships in our community. It's one of the only ways we can find out what people are doing with our systems, by asking and by being nice enough to get an answer. So we work really hard to build, as I said earlier, simple features that enable, a huge span of use cases. And one of the ways that we do that is we just listen. We listen for what people are doing. We listen for what people are saying. We listen for what they're asking for. Almost no one will ask for a feature at sort of the level of simplicity that we will ultimately build it. So nobody said, I wish there was a generic key value store. We had a lot of requests for specific versions of what Kevin just showed: versioning, state sharing, dynamic configuration within a flow, cross-run, information sharing. But very rarely was that abstracted in the way that we did it with the KV store. And this idea came out of an office hour session that we had as a company, which we have each week, and sometimes more often, we have office hours. This was product office hours. And the idea is to be able to discuss sort of blue sky ideas and see, does this align with our product vision, or is it maybe too specific or too divergent? And after surfacing a number of these use cases and these feature requests, it was identified by one of our engineers that, hey, wait a second, I think that there is actually a feature we can deliver, you just saw it, which will actually satisfy all of these if we can just show people how to leverage it for all these use cases. And so after a couple of weeks, KV Store was born. Artifacts is another version of this. So we asked a whole bunch of our customers, what do they want? What are they trying to see into their workflows? There was, we produce model training statistics, we produce confidence intervals, we produce images like the one Kevin just showed, and everyone had a different version of what they wanted. And again, we had to step back and say, is there a simple thing that we can deliver here? The ability to render Markdown in this case, that actually satisfies a huge swath of these use cases. Many of you are actually probably familiar with what we call the orchestrator pattern, which is a way of building flows of flows. So you have 5 different workflows authored by 5 different people that all deal with 5 different import sources, and then one downstream workflow that actually sort of runs the ultimate processing job. It's a flow of flows. That's not something that was natively possible in Prefect at first, and it's something that we worked for a long time to figure out, okay, what's the UI for it? What are the rules for it? How do we do it? And then the light bulb that went off probably about a year ago or so is one of our engineers just manipulated the Prefect Cloud API or the Prefect Server API to make tasks in Prefect that just kicked off entirely new flow runs and waited for them to finish. And so we introduced that as this very light, very simple feature. It very quickly became probably the second most popular bit of most popular piece of Prefect after mapping. Even though if I just describe it to you sort of in passing, you'd be like, so it's too simple. It's not a feature. It's not enough. But people built really, really interesting business use cases on top of it. And so in this upcoming 0.15.0 release, you're actually going to see our next step forward with that. It's going to become a much more robust feature. As Kevin referenced, one of our engineers, Michael, has been really working for a couple months to make that a really awesome first-class experience. But we always start here. And so this KV store to me is like a perfect Prefect feature. It is so simple, but I think everyone has encountered a workflow that relies on it. For myself, I have a flow that runs and it tells me how many people signed up for our products every day, but it's a delta. And many reporting workflows deal with deltas, right? What's the difference between today's count and yesterday's count? And so in order to facilitate that, we used to rely on external services. Some of our flows use Firestore. This particular flow used Airtable. Wonderful services, but another third-party authenticated element of a stack that has to now come into the Prefect flow. And so instead, we can use the KV store, and we just track this delta there, or track yesterday's delta there. And so there are so many minor frustrations that are solved by this otherwise very general feature. And that's really how we like to think about our product. It's a collection of things that are all individually so simple: scheduling, logging, retries, KV store, whatever they are. They're so simple, but the guarantee that we try to make is that when you stuff them together in interesting ways, you can actually build very sophisticated data applications on top of them. So I love this feature. It's one of the reasons we were excited to sort of show it today. I think it just went out in our most just a couple of weeks ago. So yeah, so thank you all for letting us share it with you. Be happy to take questions if you have them, or I can always just ramble on about any topic. We can talk about our roadmap for 1 second. At Prefect, we work in 6-month chunks. And so we're about to start our next 6-month chunk. And we have a very ambitious roadmap planned. I'm not going to share right now. We haven't made it public quite yet. But what we've been doing is we now have 3 years of data, of information, of user experiences, of user research, of just diving into this negative engineering problem. And after 3 years, there are an enormous number of patterns that have emerged. There are things people love doing with Prefect that maybe could be easier. There are things people wish Prefect did that are difficult to construct today. There are frictions people encounter in getting started. There's this enormous wealth of information we now have about how people like to use our product and what they want to do with it. And the major focus of the going forward roadmap is to take all of those lessons and actually aggressively begin to implement them in the product. This is something that we do very, very carefully. Many of you have probably built homegrown workflow orchestrators in your companies. I, as many of you know, have sat on the PMC of a very popular one in the past. When you start to say yes to everything, when you start to build things by committee, when you start to just rush forward with things without understanding if they align with the goal, you end up with terrible and frustrating pieces of software. And so we've taken our time, 3 years, to really, really, really understand what exactly people are doing. And I'm really excited that we're going to be starting to dive in on that very soon, and we'll be sharing a more formal roadmap in the near future. But versioning is one of those feature requests that we have. There is a way to do it in Prefect today, but it doesn't satisfy the breadth of use cases that we'd like it to. And so it's something that we've been looking very closely at and thinking about ways we could improve that experience. Let's see, Kevin, it's a good reminder what you put in the chat. We are hiring. We're hiring like crazy. And we'd love to talk. If you would like to come work for us, we'd love to talk to you. If you're thinking about working for us, we'd love to talk to you. If you don't think you want to work for us and you just want like career tips, we'd also really love to talk to you, because we don't know, maybe in the future there'll be something to do. So if a new job is on your horizon, with us or not, come talk to us. We'd love to chat.
Awesome. Cool. And there was one more question from Paul, which is there any general guidance / rules of thumb as to when subclassing Prefect's task class is preferable to using the task function decorator?
It's a very good question. This is actually one of those sort of sources of confusion sometimes. Hard to answer in a general sense. What I'd like to do is recommend that you use the task decorator, unless there's a very specific state or something that makes having a class object, like a proper subclass, more appropriate. So without further detail, we would recommend using the task decorator and decorating the function. But there are specific cases where it may be advantageous to go to the low-level API.
Cool. Awesome. Well, we have just a few more minutes left. Jeremiah, I would love to just hear more about, obviously I love diving into the specifics of the KV store, and also hearing more just about Prefect's feature philosophy and things like that. And with negative engineering, maybe you could just speak more to how you chose that mission for Prefect and what that was sort of like.
Absolutely. So this is a problem that I have just encountered. The Prefect didn't start as a company, it didn't start as an open source project. Actually just started as something that I desperately needed when like my analytic needs as a data scientist outstripped what Airflow was able to deliver for me in terms of speed, in terms of scale. I've been a Dask user since forever, just the very beginning of the project, and being able to push a button and spin up, hundreds of thousands of tasks running in a cluster in millisecond latency, and then turning my attention back to Airflow, where you push a button and 10 seconds later, one thing happens. It was just beyond frustrating. And so Prefect, the prototype of Prefect was actually Airflow semantics on top of Dask. And it just clicked. It was so obvious that it was just the right way to like govern data science pipelines that little project became a company, became the open source project, became a platform, and will continue to evolve. So it's really just solving a problem that I just, look, I don't know if that's a selfish thing to say. I just felt this problem viscerally in my own career.
Totally.
And then it just turned out, so did other people. So it worked out well. Luca,
Awesome.
you asked a great question here. Do you support provenance, right? Rerunning a flow in a different deployment. Yes, we have different ways of specifying affinity. So you can send a flow to this coiled cluster or that one. You can do it on a per run basis. It's another one of those things where like the exact way that you might choose to set that up will depend on exactly how you want to achieve it. But it is something that we do have sort of this flow affinity process in place.
Awesome. And looks like there's one more question in there from Ryan.
Ryan, good question. So it's a really good question. I don't think that we can make strict guarantees around, for example, a race condition. If you have two things writing to the same key, like which will win and which won't. I think that's actually a great example of where we wouldn't presume to know how to do that at this stage of the feature, or if that in fact is a useful piece of this. Our recommendation would probably be to choose a way of building your keys or extending your keys that sort of try to account for that. But I don't think that there's a way for us to guarantee that two API calls will resolve in that way at this time. We do have features like that elsewhere in the system, where you can make guarantees about state transitions being versioned, or use idempotency keys to achieve something similar. So it's definitely something that we could take back for product and dive in. But at this time, there's no guarantee that ordering of key values will be respected.
Awesome. And then Jersey asks, what would be the advantage of using Coiled as executor versus using Prefect's resource manager to spin up a coiled cluster?
I can answer that. So when you use Coiled as an executor, you are using the prefect map semantics in order to use the Dask engine. But if you are actually writing Dask code, that's when we recommend using the resource manager. So you would spin up the resource manager and then offload your Dask code there.
Awesome. Cool. I'm just looking around to see. I think we answered all of the open questions. Oh, one just popped in, actually. So it says, so Airflow can also submit tasks to a task cluster as well as a Kubernetes cluster. Are you saying that Prefect can overcome some Airflow scalability problems, even if they can have the same backend?
So I wrote that Dask integration for Airflow about 5 years ago. And as far as I know, it's unmaintained now. It was actually if it had worked, if what you were describing was possible, Prefect might not exist today. But the way that Airflow works, right, is the scheduler is a very big process. And so the scheduler visits tasks and submits them for execution. So my hope was sort of what you're implying, right? Great, we'll plug Airflow into Dask and all of a sudden we get to take advantage of Dask speed. But you'd submit a task to Dask, the task would complete, it would come back, and the Airflow scheduler on its 10-second loop would now decide that you can run another task. And so actually, when I referenced this prototype, like can we do better? The prototype was actually very similar to how Prefect works today, where we run through the entire graph that you want to submit. We submit the entire graph to the executor if compatible, in this case Dask, and then we let Dask's scheduler handle the actual latency and manipulation of data and state through the graph. Mm-hmm. So if concurrency, parallelism, and responsiveness is your priority, then you can only move as fast as the Airflow scheduler. If which I think is measured in tasks per minute at this point. And at Prefect, we talk about milliseconds per task. So if you want to submit your graph and get the sort of maximum performance that the executor allows, you have to remove the schedulers and bottleneck. And so we rely on Dask for that. So it's a question. I mean, look, if your job is slowly moving and you can submit 10,000 tasks at once and you don't need to move through your DAG, Yeah, the backend will allow that. It's really a question of how do you express the orchestration concern to the backend. And Prefect will allow you to just submit that entire graph and let the backend decide. So I shouldn't say backend, but the execution environment decide what's the fastest way to get through this without a bottleneck.
Awesome. Cool. All right. Well, these were great questions and great answers. And it sounds like, and I've been on your guys' Slack before, you have a very active Slack community where if folks think of more questions after this, they can hop in there and ask away, it sounds like. And I will, of course, send out a follow-up email with Kevin's slides and a link to Prefect Slack and some of the resources as well, all of the resources that Kevin shared in the chat above. But thank you so
Fantastic.
much. Yeah, Jeremiah.
Thank you.
And
thank you
for joining us. This was great.
Thank you so much for having us. And as you said, like Kevin, myself, our team, we're all in that Slack. It is sort of the core of a lot of what we're doing here. And we take that really seriously. The KV store comes from trying to solve feature requests that we get from users. I was in a meeting yesterday. It's a weekly meeting, right? All we do is review every feature request we've gotten. Well, every complaint we've gotten, every bit of praise we've gotten, and we go through and we really decide, is there something we can do better here? We take that really seriously. And if folks want to chat with us there, we'd be more than happy to talk. Thank you all.
Cool. Awesome. All right.
Okay, can we just, I'll just answer that last question. When's Laura doing a webinar? Laura will be online again soon. We missed her as well, but she'll be online soon.
Yeah, we do miss Laura, and she'll be doing something real soon.
Awesome. Awesome. Well, clearly you guys have dedicated fans, and your commitment to the users really shows, and it was just great to hear from you guys. So thank you so much for taking the time, and thank you to all of the attendees for your engagement and questions, and we'll see you at a Prefect and or Coiled event soon, I'm sure.
Thank
There
you.
we go. Thanks, everybody.
All right.
See y'all later.
Thanks,
Bye.
guys.
Bye.